In our last episode, The Digital Sovereign, we moved from the software to the soil. We explored the compute wars, how high end semiconductors have become the new oil, and how the struggle for silicon is redrawing the maps of global power. We looked at the compute curtain and why sovereignty in the 21st century means owning your own data centers. If you haven't heard that journey into the geopolitics of AI yet, I highly recommend you to pause and check out episode 4. It explains the where and the who. Today, we are specifically going to talk about the how. Specifically, how we live with a technology that is smarter than us, but perhaps less kind. In 1980, a loan application was a human story. It was slow, paper heavy, and relied on a bank manager's intuition. Today, the same decision takes just 5 seconds. It's handled by an algorithm that doesn't know your face, your history, or your heart. It's peak efficiency, but the efficiency has a shadow. Welcome back to the Horizon Shift. I'm your host, Avishek Roy. Today, we are asking, can math be prejudiced when we trade human judgment for machine efficiency? What do we lose in the bargain? To understand why AI makes mistakes, we have to look at its diet. AI is essentially fed on data, millions of lines of our own history. And truth be told, our history is messy. Think of Safia Noble's groundbreaking work in algorithms of oppression. She argues that search engines aren't neutral portals. They are mirrors of societal biases. If you train a model on a world where certain groups have been historically marginalized, the AI doesn't fix that history. It just automates it. Take the real world example of Amazon's experimental hiring tool. What the Amazon executives wanted was to find out the best resumes. The AI looked at 10 years of successful hires. Most of them were men. The result? The AI began penalizing resumes that included the word women's, such as women's chess club captain. It wasn't told to be sexist. It simply found a statistical correlation between being male and being successfully hired. Or let's consider the ProPublica investigation into the Compass algorithm used in the US courtrooms to predict recidivism. The study found that the black defendants were nearly twice as likely to be misclassified as high risk compared to the white defendants, a staggering 45% versus 23%, while the white defendants were much more likely to be incorrectly flagged as low risk. This is the echo chamber of data. The AI's room of a million light bulbs from episode 1 doesn't understand justice. It only understands patterns. And if the pattern is broken, the decisions will be broken too. But what happens when the decision isn't simply a loan or a job interview? What happens when it's a matter of life and death? Let's step into the self driving car. Imagine you are in an autonomous vehicle. A group of pedestrians suddenly appear. The car now has two choices: swerve and hit a barrier, likely killing you, who is the passenger, or stay the course and hit the pedestrians. This is a classic example of the trolley problem brought to life in code. MIT's Moral Machine experiment collected 40 million decisions from people in 223 countries. They found cultural values differ wildly. Some cultures prioritize the young, while others prioritize the elderly. Some prioritize the many versus other prioritizing the few. Now, if you follow utilitarianism, think about Jeremy Bentham or John Stuart Mill. In this case, you save the greatest number of lives. Pure math. But if you follow deontological ethics, like Immanuel Kant, you might argue that the act of swerving to kill an innocent passenger is inherently wrong, regardless of the numbers involved. So, who gets to write that code? Is it the 24-year-old engineer in the Silicon Valley? It gets even more subtle. A 2019 study published in The Science by Obermeyer et al. Examined a healthcare algorithm used for 200 million people. The AI was supposed to identify patients who needed extra care, but it used healthcare spending as a proxy for need. Because of systemic economic disparities, the AI virtually concluded that Black patients were healthier simply because less money was being spent on them, even when they were actually much sicker than their white counterparts. Now, think of Elias, our architect. If he's in a hospital during a crisis and an AI is allocating ventilators, it might use a quality adjusted life year or Cali metric. It sounds very efficient, but Cali can inherently devalue the lives of people with disabilities. You are asking machines to perform moral algebra without giving them a soul. So, how do we fix this? Without destroying the efficiency that makes AI useful, we need a systemic plan of action. We can't just patch bias, we have to re engineer the process. And this consists of four primary phases. Phase one, the pre training audit, which enables diverse sourcing. Before a single line of code is written, we must audit the data. We need data diversity officers to ensure that the training set isn't a monoculture. If the data is skewed, we use synthetic data to balance the scales, ensuring that AI sees a representative world. Phase 2 consists of adversarial debiasing during the training. Here, we use a red team approach. We build a second AI whose only job is to find bias in the first one. By using fairness constraints in the loss function, we tell the machine, be accurate, but if your accuracy comes at the cost of disparate impact, you fail. Phase 3 is the right to explanation post deployment. Borrowing from the European Union's AI Act and the White House blueprint for an AI Bill of Rights, we really need explainable AI. If a bank denies Elias a loan, the black box must be able to output a human readable reason instead of just saying the computer said no. Finally, phase 4 is the human circuit breaker. So, for high stakes decision, for example, in case of legal, medical, or financial scenarios, a human must always be in the loop. The machine provides the 0.042 probability, but the human provides the context. We need something like an FDA for algorithms to certify that these systems are good before they go live. We often hear the term that tech is neutral, but a tool that gets to decide who gets a home, who gets a ventilator, who lives through a car crash is never neutral. It is just a crystallized version of our own values. The efficiency trap reminds us that speed without empathy is just a faster way of making mistakes. We cannot automate our way out of being ethical humans. We are the architects of the ghost. Hence, it is our responsibility to ensure that the ghost serves everyone. Next time on the Horizon Shift, we are going beyond the screen. We will talk about the evolution of tech and specifically about the death of the smartphone. What happens when internet isn't something that you look at, but something you live inside of? I am Avishek Roy. If this journey into the shadow of the machine sparked your curiosity, please subscribe on your favorite platform and share this episode with someone who values a fast answer over a fair one. Always remember, we must demand not just efficiency, but fairness. See you on the horizon.